Okay, welcome back to our image sorter beginner Golang project. We've made a lot of progress recently, and we're kind of at this stage here where um, we're printing out records where there are multiple locations. It doesn't look good. Um, it'll only print out one location, so we need to fix that up. Um, but we're kind of at the point where we can do that. Now, I think for today we need to start building this function to handle duplicates. This one here, I think we'll remove the functionality that's printing out the multiple locations for now, and we'll handle it in this function here, because then that's going to ask the user, hey, for this file here, it exists in multiple places. Which one do you want to keep? So we'll do that in this function here. Maybe we'll have a separate way of handling it in the future. Maybe we can have like a dry run where it will go through and um, just print out all the places where there's duplicates, but not actually delete anything. Um, so let's go back to our image sorter application and just do a quick recap of where we're at. So in the previous video, we kind of got all of our DB stuff sorted where it was going through recursively hashing the files and then um, and then storing them in the DB. And then each time that file hash is seen with a different location, that is also stored in the DB. So we've got all of that handled. That's the main sort of thing to find the duplicates. So we're getting very close. Now we do all the setup here. One thing I am worried about is this main function is getting quite big and unwieldy. Um, so I do wonder if we should move all of this somewhere else. So, okay, let's leave this stuff here for now, but perhaps going forward, we'll make sure that we're not doing everything in this main function. Let's start by removing this read part here. Okay, so this is the part of our code where we read from the DB and we print the results where there are duplicates. Now that let me just demo this actually, because then we can see what's going on here. So let me just build, just in case there's been any changes. Just want to make sure that the code we have is exactly what we want. So image sorter, right? So this is kind of the situation we have. So this is the hash. It's rightly found that there are duplicates of this, but the location that it's showing us is only the first location that it has found. So we don't have all the locations where this hash exists, only the first one that it finds. That's not quite what we want. We want to have all of the duplicates. So back in our code, um, we can probably remove that for now, because it's not really doing what we want. So here where we have read DB and print results where there are duplicates, let's instead change this to handle duplicates. and this is where we should really just call another function, handle duplicates. Um, so let's remove everything here. Okay, actually, maybe now is a good chance to learn another another vim command. Let's throw this in there um, as something else that we can learn at the same time. So vim delete. Uh, what do we want to do? We want to. So we're on. This is relative line numbers. So here you can see the cursor is on line 0, and then it goes all the way down 19 lines. So what we want to do is delete. No, sorry. What we want to delete is from this one here down to this line here. So we want to delete 19 lines below. So delete 19, 19 lines from cursor. So here we go. Trusty old Stack Overflow. Okay, so the delete X command will work nicely. Okay, so plus comma $D. This will delete all the lines from current +1 till the end. Okay, so we don't really want to delete until the end because there's still one line that we want to keep here. So to delete the next 2 lines, the following range would work: +1 +2, or shorthand +1 +2. So plus comma +2 delete. Okay. I mean, is there a simpler way to do it? Um, I thought there was a simpler way where you just give it the number and then delete. Something like this. Yeah, this one here. Okay, so yeah, DD. So the number of lines and then DD. Let's see, does that work? So what do we have? We've got 20 lines. So just making sure we're not in insert mode. We're in normal mode. So 20 DD. Okay, that works. Okay, that's way better than the other suggested solution. 20 DD. Okay, there we go. We've learned some more. We've learned some more Vim today. Okay, so now we need to create this handle duplicates function. So, func handle duplicates, and let's just give it a print line. So hello from handle duplicates. Just to start off, making sure that we haven't made any mistakes so far. Cool. Nice. So hello from handle duplicates. Let's go back in there then. Now, for handling duplicates. Okay. This is where I think the way that we've okay, so just what I'm thinking at the moment. So um right. So oops. Um I'm not sure how to remove once something's already highlighted, how to remove them. Anyway, Okay, so we have this handle duplicates function here. The thing is, we're going to need access to the DB, and the DB is in the main function. So how we've been handling it with this function here is by passing in these statements. I think these are the insert statements, um, which is kind of not a great way to do it. Um, so I think the better way to do it is to be passing in um, this essentially the DB itself. So I mean, we've got DB, yeah. So we've got our connection to SQLite. Really, we just need to pass in this connection here. Um, and this 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 type here is the SQL. So here, okay, I got a bit confused in the last video and kind of just got through and got it working of like, oh, okay, this is the type that we have to pass in here. And I was a little bit confused about the asterisks here. So this is the pointer. So the type here is a pointer to this SQL. Um, so we can do the same thing. Um, we can do the same thing here. Let me bring up the Golang SQL documentation. Okay, so here we have this DB type DB. So DB is a database handle representing a pool of 0 or more underlying connections. So this is what we want to pass in. It's safe for current use by multiple Go routines. So that's good. We can speed it up later by having multiple Go routines and all kinds of things. The SQL package creates and frees connections automatically. It also maintains a free pool of idle connections if the database has a concept of per connection state. Um, Such state can be reliably observed within a transaction or connection. Once DB begin is called, the return transaction is bound to a single connection. Once transaction commit or transaction rollback is called on the transaction, that transaction's connection is returned to the DB's idle connection pool. The pool size can be controlled with DB's set max idle connections. So if we can pass this in, then we can use the DB um, without needing to um, do verbose and messy things like this, like passing in these statements. Or here we have it as a global variable. So this is messy and not good. Um, on a it's okay for this small script that we have, but on a bigger program, say you've got multiple developers working on it, this is going to get messy really quick and cause a lot of problems. So going forward, we can refactor that later, but going forward, let's find a nicer way to do this. So I think what we need here is the we need to pass in the DB, and this is the SQL DB, but it's a pointer. It's a pointer that we're passing in. So here we should be able to pass in DB, seeing as though that's what we're already calling it back here. So we've created this variable here, and that's where we'll pass it in. So we should be able to use the DB in this new function, just like we've done here. We can create these queries and then execute them. And that way we don't need to, create these things like in the main statement, chuck it into a global variable and then use it from here. Now we have full access to the DB. So let's just make sure that works. So um, yeah, I guess Go will give us an error if it's not working. Um, so yeah, should we? Okay, let's just see how we go so far. So we'll write that, we'll build it, and then um, let's run it. Okay, good. So we're still getting there. We haven't got any errors yet. So it looks like we should be able to do that. Okay, great. So um, now where are we? Handle duplicates. So in this function, we want to um, create a query to get all of the duplicates. So let's just call it query for now. And now we need to work out, okay, what does this query look like? So it's going to be select, and then from here, we're going to have to work out what we're doing. So we have a DB model here. So here we have our files where we store all of the hashes, and then locations here where we have again the hash and then the file path. So every time we find a file, we store where the file path is, as well as the hash. Now, duplicates are actually going to be easy to find, really only using this table here. We kind of don't need to use this one. We kind of don't need to use this one at all, really, because we can find these locations here where the hash is more than one. Where grab all the locations where the hash is more than one. Um, so let's go back. Let's go back to our code and start putting together the query. Um, so um, okay, so select. So really, we can grab. Okay, so select hash. So we're just going to grab this field here. We'll grab all the hashes. Where's my, yep, from locations. So again, this locations table. Then, so if we do that, we're going to get all the hashes that exist, every single hash that exists in this table here, all of the rows of this table. But what we want to do is we want to group by hash. So use the hash as the kind of unique field that we're going to group by. So only show the hash once. And then we kind of want a bit of a where clause there. We don't want to only just show all of the hashes there. We only want to show them where there's more than one in the table. So here we can do a similar thing that we did. Um, oh, I've deleted it, but what we did in the previous query, where we used having um, and do a count uh, of greater than one. So this is everything. So we don't need to be very specific here because we're only using the one table. So if we select uh, get all the hash fields from this locations table, group them by hash. So only show the hash, the unique hash once, and only show them where there's more than one. Um, Now we need to go through. Well, I suppose we need to execute that query first of all. So let's go back to our reference. So the Mat was it Mat N SQLite 3? Um, yeah, here was the simple. Here was the example that we followed before. Um, yeah, so this is the example that we followed before. Um, where we execute that query and then we iterate through the rows to print out all of those there. So um, this DB this DB query and I mean where's the actual source documentation as well? Um, so yeah, this function here. Um, yeah, so we can do this here. This one's actually a little bit more complicated. So we'll stick with the example that we have. But what we get back are these rows or an error, and we need to handle that. So let's um, let's use this example here. So we'll get back rows error and db query. We use the query here. Then um, we'll handle the error. So if error is not nil, format log fatal error. Okay, and then we need to actually iterate through the rows. So we'll defer closing the rows, and then we'll iterate through them. So for rows next, here we need to set up the variables. We're only grabbing the hash. Um, you know what? Let's grab the location as well. While we're grabbing hash, let's grab location. Actually, sorry, not location. What did we call it? File path. Let's grab file path too. Um, Actually, no, sorry. Hash only for now. And then we'll do a separate query. We'll do a separate query to get all the locations for that hash. Um, but for now, we'll just find the duplicates. So var string strong var string hash, and then we need to scan those rows to grab to grab the result and chuck it back into this variable. So rows scan. We've only got one field that we're passing in here. So that's our hash. And actually we need to handle that error if there is one. So if error is not nil, log fatal error. And then yeah, let's print it out for now. Format print line hash. We'll do more with it later. We'll do more with it later because we're going to want to again use this hash in another query to get all the locations. But for now, let's just print it out and make sure that this part is working properly. So then we'll handle this error here, any errors that might have come up. So error is rows, and then this error function here. And if error is not nil, log fatal error. Great. So we'll handle that there. All right. So just a quick recap. We've got this select query here where we grab all of the hashes from the locations table, where there's more than one of them of the unique hashes. And then we'll just, from that query, we'll iterate through all of the rows, store that hash in this variable here, and then print it out. If there's any errors, we'll log those out too. So let's build, make sure we haven't made any mistakes, but we have. Okay, so declare to not use string. Did I mess up the syntax there? So 145. Okay, yeah, that's the wrong way around. So var to declare variable hash, so the name and then the type. So I mixed that up the wrong way around. I'm guessing these will be resolved from that. Yes. Okay. Good. So let's run it. And cool. Okay. So this is looking good. This is that hash that we've found. Where we have that duplicate file. This is the hash of the duplicate file that we found. So now we just need to do another query where we can grab all the locations for that hash. So we can do another select here to get all the file paths. So select file path from locations where hash equals this hash here. And then we should get all the locations. Okay, so let's get all the file paths for this. So let's get back into our code and as part of this query here, so as we're iterating through all of the rows that we have returned here, we probably want to grab the locations at the same time. So just thinking, we're gonna have to store those. So Okay, yeah, we're gonna have to store these. So let's, I'm not entirely sure. Let's do this. Let's get all of our variables defined up here. So var hash string and um what else are we gonna need? We're gonna need to have var file path. I this name might not be intuitive because I keep on having to come back and reference this. So yeah, it's probably too late to change now, but now um I'm not entirely sure how this is handled in Go, but I think this is the way we do it. We want kind of like an array of strings. So file path, um, file paths, yeah, file paths, and they're going to be an array of strings where we kind of keep on adding to them. Now, I'm not too sure how this works in Go. Is this is this similar to Python, where you don't have to define how big the array is and you can just keep on chucking stuff in there? Or is it the same as C and you have to define how big the array is from the start? Not entirely sure. I guess we'll find out. Um, um, okay, and also Go has slices as well as arrays, and I think a slice is different to an array. Maybe a slice is kind of similar to Python, where you don't need to define the size of it. We'll probably have to look into that a bit more a bit later. But for now, let's see if we can just chuck all of the file paths that we grab into this array here. Um, so then here, so we can get rid of this variable declaration because we've done it further up. We've done it here now. Okay, so this, as we're going through these here, we have the hash. Okay, so we print that out, but now we want to get all of the file paths. Um, so this is where we're going to need another query. Um, I think do we define that as well? Ooh, probably right. So okay, let's rename this one to hash query, and then before we forget, do it straight away in here. Whoops, hash query. I didn't have to delete that. So hash query. Then we also want the file paths query. So here we're going to have select not in this case we want the file path. So select the file path from locations where hash is equal to the hash that we pass in. So we kind of saw this before, where we had the question mark syntax. So that leaves the space there for that's where the hash will get passed in. So we did this here. Obviously, this is slightly different, this insert statement, but it's the similar sort of idea where you've got this question mark. So we can do that with our select statement as well. So select file path from locations where the hash is, and then the hash that we pass into it. So now we can run that query. So we're going to do the same thing here. Um, now we can't use rows again because we've already used it. So let's use path rows. So path rows or error, and then db query, and here we're going to use, I forgot what we called it already, file paths query. File paths query. Now, this one, so here hash query um, is fine, but here we're looking for something else to get passed in. So this is where we need to also give it the hash. So the hash that we get from here, that's what we need to pass in to the query. So then that will replace the question mark with the hash that we pass in. So now we need to go through the same sort of thing. So handle the errors. If error is not equal nil, I should just save this chunk here as a little template and then just paste that in. The amount of times that we have to type this in Go is crazy. Let me know if there's another way of handling errors. It seems like this is the Go way of doing it, but it does seem very repetitive. So I suppose in reality, for a bigger application, you'd be handling all these things very differently. We're just doing a very, very simple, just log out the error. So you'd probably want to do a bit better error handling, but it does seem very repetitive. Great. So we're getting these path rows now. So okay, yep. So we need to defer closing that as well. So defer path rows close, and then yeah, then we need to iterate through those as well. So for path rows next, we've got now, so error equals path rows scan, and here, okay, so we've created this oops, where was it? This array, and again, sorry if I'm using the wrong data structure, the wrong type, sorry. Created this array here, but maybe we need a temporary one for storing the path, that we have. Where are we? Rows pass next. So yeah, let's create a temporary one here. So var file path string, and file path. So we can chuck that in there. Where's the reference that we were working from? Okay, handle handle errors again. So if error is not nil, log fatal error. Okay. Let's just print each of these file paths. So we'll print out the file path. Excuse me. But what we kind of want to do is we want to append it to this array here, because okay, sorry, my headset died again. The battery seems to be broken on this thing, and it just dies suddenly. Right, so we are grabbing the file path here, and we're printing it out first, but what we really want to do is we want to chuck it into um, append it to this file paths array. I'm going to take a guess at this. Again, I should probably go to the documentation. Um, but file paths, I'm going to make a guess that we can use an append function. That changed color. I don't know if that's a good sign or not. File paths append file path. All right, let's see if that works. Okay, so um, yeah, okay. Let's see. Let's try and build this. So at a bare minimum, we should be getting these file paths printed out. I'm not too sure about this append function. I'll go to the documentation if that doesn't work. So go build. Uh, okay, undefined type string has no field method. Okay, that was a wild guess. So yeah, that was a wild guess. Okay. Um, let's remove it for now. I'll go to the documentation later and work that out. Um, so let's remove that. I'm gonna have to remove it from here as well because otherwise Go will complain that I've got an unused variable. Okay, so let's give this a run. Um, image sort xe. Okay, awesome. So this looks like it's doing what we need it to do now. So we've got the hash that it's found. It's worked out that there's duplicates of these, and now we're getting every location where it's found those duplicates. Um, so just to double check, Explorer exe, here's the first one, and will it bring up the file straight away? No, it doesn't. Oh, whoops, I've added that after. Okay, so yeah, here's the first one. Here's the second one. Same file, good. And then just for completeness, uh, explorer.exe. There's the third one. Cool. So yeah, so it's doing what we need it to do. It's finding the hash with duplicates and then outputting all of those. So um, yeah, so it would be nice to get these all in an array um, so that we can work with them later. Because then we can throw up things for the user to say like, hey, look, we found this. So file with this hash exists in multiple locations. Which one do you want to keep? And then this can be 1, 2, 3, and then the user can select, okay, I want to keep number 1, and then it'll delete the other two. Or select 0 to skip if you want to keep all of them. So yeah, it would be nice to throw those into an array. Um, Maybe we look at doing that next time. Because then we can kind of attack it from a fresh perspective. We'll go to the Go documentation and see how arrays work. Maybe we can look at that for a little bit as well, just so that we all have a good understanding of this data type, this how this is handled in Go, because I suspect that I'm using the wrong terminology here. I don't think there are arrays. There are arrays, there are slices, and they work differently. So I think in the next video, let's take a look at that and understand how that works, and then we'll use that for our for storing all of the locations that we find. Um, so please uh, like, subscribe, comment. Let me know if you like this. Let me know if there's anything that you want to change. Otherwise, please, I hope you're enjoying the journey and please continue on to the next video. Thank you.